Top Secret Sci-Operative Training Mission. Reading Passage Law of Conservation of Energy. Mission Understand kinetic and potential energy and the conservation of energy. Tips Remember to beam as you read through the passage below. To aid you in your quest to defeat the Hive, I've created a new piece of gear for you to utilize. Jump boots. They store potential energy, and once released, they will convert that energy into kinetic energy to allow you to extend your movement and reach new heights.
Thank you, Dr. Watt. The jump boots will definitely give our PsyOps team the advantage over the Hive in our missions. Could you explain how it creates potential energy and kinetic energy so that I can relay the information to our team?
The jump boots do not create energy, instead, it transforms it. The law of conservation of energy states that we cannot create nor destroy energy. It can only be released or absorbed to transform from one form of energy to another. The jump boots transfer kinetic energy into potential energy and back into kinetic energy. The larger jump is created by increasing your potential energy or the energy stored within an object by either a change in height or shape. Changing the shape of an object to store energy gives the object elastic potential energy. In a normal jump, you compress your body. By doing this, you're supplying your body with elastic potential energy that will be released into a jump. In the diagram to the right, we can see Nikole compress her body, which allows her to jump up. Energy can be transformed from one form to another, and different forms can be used for different purposes. The jump boots have a battery that uses chemical energy to create electrical energy. The electricity moves through a coiled wire to create thermal energy that warms air in the jump boots. The heated air is released to give you an even greater jump. As you rise higher in your jump, you'll gain gravitational potential energy. This energy is formed as an object's height increases and stores the energy to oppose the force of gravity. Once you start to fall, all of the stored gravitational potential energy is converted into kinetic energy. The diagram to the left shows the places in the jump boots where the forms of energy are found. Chemical energy is in the battery, electrical energy is in the coiled wire, and thermal energy comes off of the heating element. The exhaust is where pressurized air exits the jump boots to help Nikole jump higher.
Wow, so much energy is used in the jump boots. Could I find out exactly how much gravitational potential energy I have gained?
We can calculate that. Gravitational potential energy is the product of your mass, the acceleration of gravity, and your height. Your mass measured in kilograms should stay consistent on the field. The Earth's gravity is always 9.8 ms squared. Your height in meters will change depending on how high you are from the ground. Gravitational potential energy equation. Gravitational potential energy, GPE, equals mass, m, multiplied by the force of gravity, g, and the height above the Earth, h. The force of gravity, g, is equal to 9.8 meters per second squared. Kinetic energy equation. Kinetic energy, Ke, equals 1/2 multiplied by mass, m, and the velocity, v, squared. Many units are used in both equations. Mass is in kilograms, kg. Height is in meters, m. Velocity is in meters per second, which is written as a fraction with m divided by s. GPE and Ke are in joules, J.
So, a normal jump would have less gravitational potential energy because the height is smaller. Do we have a unit to measure this energy?
We do. Scientists agree on an international system of units, or SI units, to stay consistent. For all forms of energy, the SI unit is joules, J.
I'll be able to jump right over the Hive. Will I always have that gravitational potential energy after I jump?
What goes up must come down. Your gravitational potential energy will decrease as you fall back towards the ground. The potential energy transforms into kinetic energy, which is the energy possessed by an object in motion. The word kinetic comes from the ancient Greek word kinetikos, which means simply to move. Anytime an object moves, it has kinetic energy. Some forms of kinetic energy happen at the molecular level. When air is stored inside your jump boots, it is heated so that the particles begin to move faster. You can also use the equation to solve for kinetic energy.
I have to jump onto cliffs in the hive base, so how do I figure out how much energy I need to scale them? There are so many types of energy involved in the jump.
Instead of looking at each energy individually, we need to think about them working together as a system. So we will take the sum of the kinetic energy and potential energy to find mechanical energy. I've created a computer simulation to demonstrate what is happening as the energy transfers between kinetic and potential energy. Computer readout 1. The jump boots release the pressurized air to thrust Nikole upward. It will be a quick change in velocity, so kinetic energy is high. This is why, in the diagram of Nikole jumping below, the kinetic energy is 10,000 joules and the potential energy is 0 joules. 2. As Nikole is rising in her jump, kinetic energy decreases because she is slowing down, and gravitational potential energy increases because her height is increasing. The kinetic energy decreases to 5,000 joules, and the potential energy increases to 5,000 joules. 3. At the peak of Nikole's jump, the kinetic energy has fully transformed into gravitational potential energy. This is why the kinetic energy is 0 joules and the potential energy increases to 10,000 joules. 4. As Nikole starts to fall, her height is decreasing, so gravitational potential energy decreases. Also, her speed would increase, so kinetic energy would increase. This increases kinetic energy to 5,000 joules and decreases potential energy to 5,000 joules. 5. Right before Nikole fully hits the ground, her potential energy has transformed back into kinetic energy. Her kinetic energy is 10,000 joules, and her potential energy is 0 joules. Throughout the entire jump, mechanical energy stays constant because it is the sum or combination of both potential energy and kinetic energy. This is why mechanical energy is 10,000 joules at every step in the diagram.
I need to test these jump boots so I can start calculating the energy needed to jump the right height.
Make connections. In each box, write a connection between the text that you just read and either your prior knowledge or something in your life. Reading comprehension questions. Law of conservation of energy. 1. What is the law of conservation of energy? 2. Define mechanical energy. 3. Create a formula for mechanical energy. 4. Complete the table below to compare potential energy and kinetic energy. Focus question. How is this defined? Complete for potential energy in the first box and kinetic energy in the second box. Focus question. How do you increase this? Complete for potential energy in the first box and kinetic energy in the second box. 5. Describe how gravitational and elastic potential energy are different. 6. Nikole is testing out the jump boots and calculates it will take 250 joules of mechanical energy to jump onto a cliff. Partway through the jump, her calculations have her at 115 joules of kinetic energy. How much potential energy is contained in the jump boots? Show your work and include units. 7. Nikole is trying to determine if the gravitational potential energy or the kinetic energy equation would be appropriate for the scenarios below. Explain your choice for each. A. Nikole is trying to determine how much energy is needed to jump down a cliff. B. Nikole is falling down the cliff. 8. In the problem below, box the information that would be needed to calculate gravitational potential energy, circle the information that would be needed to calculate the kinetic energy, list below the problem any information that is not included, but you would need to calculate either potential or kinetic energy. Nikole, with a mass of 80 kilograms, is jumping up to a 15-meter cliff. Mid-jump, she has a speed of 7 meters per second. 9. In the laboratory, you will be able to improve the axle compressor and upgrade the heating coil for your jump boots. This will increase the stored potential energy. How will this affect the height that Nikole can jump? Explain. 10. Astronauts are able to jump much higher on the moon than they do on Earth. What does this tell you about the gravitational potential energy on the moon compared to the Earth? Explain.